Hi, everyone, and thank you for joining. Everything happens somewhere. We'll be covering spatial, match, and distance today, and we'll be doing some a little bit more intermediate work than we did last week when we started out with geocoding and creating trade areas. So now that we've started with the basics of that, and you've got geocoding and trade areas down, we'll be moving forward with that into spatial match, which is a bit more intermediate level GIS technique. So here on our agenda today, we're going to cover spatial match, distance analysis, and we're going to do a spatial match with some EXPERIAN demographic data. I'll then open it up to Q&A afterwards. So I did want to provide a quick overview. I am Deanna Sanchez, and I'm very privileged to be in Alteryx ACE. I'm also a senior consultant at Technion Data Solutions, and I've been using Alteryx since 2005. I don't even want to count how many years that is now. Almost the last century. I've been co-leading the Dallas Alteryx user group for 5 years now, and we are now at over 300 members. And I launched the Fort Worth Alteryx user group last year, and we are now up to 50 members and growing as well. Today, again, we're going to cover spatial match. And so I wanted to give a quick overview of what is spatial match and how does it work. So as you can see on the screen, we've got two separate layers, and these may look familiar if you joined last week's session. These are some customers in Colorado and some stores and their trade areas in the Denver area also. So with spatial match, you actually overlay separate map layers onto each other. So these must be aligned and overlaid in the same geographic location on the Earth's surface. You're basically doing a three-dimensional overlay. You're looking at where these two map layers intersect and how do they intersect through space upwards vertically. So where do those customers overlay onto those trade areas for those stores, for example? Performing this overlay or spatial match process really gives you insights into the spatial relationships between these layers. You know, in the old days, before we had computer GIS, not that I'm that old, but I heard that you would have to overlay clear vellum map layers, one on top of the other, physically, as if you were overlaying two pieces of paper. And they would line those up, and then you would look through and see the relationships between the map layers. So thanks for technology. Now we have computers that can do that. And now we can actually overlay these layers here in Alteryx as well as other software systems. So for the tool requirements, there are two separate geographic layers that you'll see me do today in the demo. One is a target and one is a universe. And when I get into the spatial match tool, I'll explain a little bit more about that. Then you choose your geographic interaction. Is it within? Is it contained? Does it intersect, touches, and so on? The next thing we'll do today is distance analysis. So this is very, very fast in Alteryx. So as I mentioned last week, Alteryx runs in virtual memory, so it is blazingly fast. And when it calculates distance, it is extremely fast in that respect as well. So you'll see me pull in, you know, the customer data and calculate those distances, and it runs in just a few seconds for that straight line distance. So a distance, we are doing a distance between a source and a destination, such as customers to stores, and it utilizes spatial object fields. So if you joined us last week, you saw how a latitude and longitude after geocoding actually is converted to a new field that holds a spatial object. In Alteryx, it can hold a point, polyline, or polygon. So the spatial object field is actually what's used to calculate that distance using the distance tool in Alteryx. We have a lot of outputs for the distance tool, which you'll see today. You can do a straight line distance, or as we say in GIS, as the crow flies. You can also do a drive time distance. So how far are they actually driving in miles along the street network? And you can find out the drive time minutes. How many minutes are they actually driving? So these are very different than that straight line distance, which doesn't take into account road networks or crossing over lakes or mountains or any other geographic attribute as well. So the drive time process uses TomTom data behind the scenes, and that's the same kind of data set that's being used in geocoding as well. So you have very fresh data. It is updated quarterly in Alteryx. And with distance analysis, you can do your units in miles, kilometers, feet, and meters as well. We'll also do a find nearest analysis. So this is a distance analysis, again, between a source and a destination. It utilizes those two geographic layers, the target and the universe, which I'll explain more when we do the demo. And it does find the nearest 1, 2, 3, and more locations. So if you want to find the 3 nearest stores to your customer, you would use this tool. Again, this tool is extremely fast. So you'll see it run today and how quickly it can calculate. Again, you have those same distance tool outputs, straight line, drive time distance, drive time minutes. We are using TomTom data for this. And for find nearest, the units are in miles and kilometers as well. And then we'll dive into demographic data. So in the interest of time, we can't really do a deep dive into the incredible data sets that are provided by EXPERIAN in Alteryx. But there are over 1,600 variables. These include current year basic variables and 5-year projected variables. They also include the census variables from 2010 and 2000. You also have the very cool mosaic lifestyle segmentation data. And as I do the demo today, we're going to actually utilize that data and profile the customers and actually match them to their spatial boundary and figure out what their lifestyle segmentation is. The EXPERIAN data set also includes consumer expenditure and retail demand as well, and plus much, much more. So again, in the interest of time, we can't dive into all the variables, but there's an extreme amount of really highly robust variable data sets in the EXPERIAN data. They also provide numerous geographies. So we have block groups from the census and census tracts. You also have congressional districts from the 114th districts, and then the DMA or designated market area. You also have metro and micro core-based statistical areas, as well as cities and states, zip codes, and of course, much more. I couldn't put it all on here or the font would get really, really small on the PowerPoint. So I'm excited to show you that today. I've been using the demographic data in Alteryx since 2005, which is actually one of the ways Alteryx began. It actually started as one of the tools that you'll see today, the allocate tool set. And in 2005, that's actually what it was. It actually performed geographical calculations and pulled in some demographic data. I've actually been doing demographic analyses since 1997. Last century. And my degree's in GIS, so I really enjoy doing this type of spatial and demographic analytics. And so with that, we'll actually go into the demo itself. We're going to use the customers and store data set from session 1. We're going to perform that spatial match, distance analysis, find nearest, and the demographic data append. And we're going to understand the spatial interactions as we move along in this. So with all that we're doing today, we're going to be able to ask even more questions than last week. So last week we could calculate how far away are my customers from the stores once they were geocoded, but now we can calculate how many minutes are they driving to each store, and we can even look at the data and start to ask, are they driving past a store to shop at another of my stores? So that will give us some insight as well. We'll also calculate what are the 3 nearest stores to each customer with the distance outputs listed there. And we're actually going to see how do you match your customers spatially to demographic data. And then we'll calculate what are the top 10 segments of the customer base. So this way we can hone in on those customer profiles and maybe start to look for where those customers may be untapped in new areas. And that will lend itself to session 3, where we touch into site selection and advanced spatial analytics. So with that, I'll go ahead and share my screen and start with Alteryx. And here is Alteryx. For those of you who weren't able to join last week, you can see the canvas here that we build our workflows on, the configuration window that will change with every tool that we bring to the canvas, and then our results window that will not only show results of the analysis, but it will give us transparency into every single step of the workflow, and it will let us know exactly what's happening with the workflow as it runs. So for those who were able to join last week, we did create geocoded customers, and we'll be using that data set today. And we created a stores and trade area data set as well. You can see the extensions are YXDB. These are Alteryx database extensions. So this is a native file format for Alteryx, which you can output to. And there's a really good reason why I've output to a YXDB. And the reason for that is that in an Alteryx database, you can actually store multiple spatial objects per record. So you see here I've got record 1, which is store 100. I have a store spatial object, which is the store point. And I have the trade area spatial object, which is the polygon around the store. And I can associate both of those with one record. So this is a great advantage of Alteryx and of storing it as a YXDB. And as you can see here, you can use those YXDBs in future workflows. So I'm going to add a browse tool now. I'm going to actually browse into the data and run the workflow so that we can refresh our minds and remember what the data looked like from last week. And one of the reasons I love using a browse tool with spatial data is if you have the spatial object field that is created in geocoding with latitude and longitude for points or boundaries for trade areas, if you use the browse tool, you get a nice map and then you can see your data spatially. And since I'm a very visual GIS type person, I love to see my data visually, and I love to confirm, yes, all of these customers are in the Denver area. This does look like the data set I'm looking for. So here you can see the customers that we geocoded last week. Click on the browse tool for the stores and trade areas. Here's the same area, the 10 stores in Denver, with each of their individual trade areas attached as well. So these are 10-minute drive times, which we discussed last week, and how drive times work. And drive times really are a best practice if you're really looking at customer data and wanting to know where your customers are coming from. So especially if they're driving it to a store location, you can really use that drive time. And that drive time, as you can see here, will not include parks and lakes and so on. It will actually drive around it. So that's really a best practice when you're looking to properly profile your customers and see really where are they coming from and how far are they driving and how long are they driving to get there. So now that we've reviewed the stores and the trade areas from last week and our geocoded customers, we'll actually pull in a spatial match tool. So to do that, I'll go to the spatial tool category. And now that we've done our geocoding and used our trade area tool last week, we're going to do more intermediate work this week. So we'll be pulling in the spatial match tool. So as I pull this tool in, you can see there are two inputs here. There's a target and a universe, or that T and that U. So a best practice is if you have polygon and point data, as we do here, with the trade areas being the polygons and the customers being the points, the target should be the larger area or the larger polygon. So the trade areas will be our target, and the customers or the smaller points area should be my universe. So I'm going to match my universe to my targets. The same is true if you have polygon to polygon matching. Say you're doing block groups within a city boundary. You would actually use the city boundary or the larger polygon as the target and your smaller polygons as the universe. So that's just a best practice to keep in mind when you're using the spatial match tool. I'm going to go ahead and drag here and connect to the targets for my trade areas and my customers for the universe. So for those new to Alteryx, every time I bring a tool to the canvas, the configuration for that tool shows up in the configuration window. So now I'm configuring my spatial match tool. So you can see here for my target in the spatial object field, I actually renamed my spatial objects last week when I created the trade areas so that it doesn't say spatial object and spatial object. Now I've got store spatial object and trade area spatial object. I'm actually wanting to match my customers into the trade areas and not point to the store. If I did points of customers to the store point, that would imply that maybe a customer is living right at the store. And hopefully that is not happening. So what we want are customers matched to the store trade area. So I'm switching that spatial object field. In my universe, I just have that one spatial object coming in. That's the customer spatial object. And down here, I actually have my options for how I want to look at that spatial relationship in a spatial match. So I have an option for where the target intersects the universe. This is where those points are intersecting inside of that trade area. I can also do target contains universe, and that trade area actually contains the universe completely. I actually want to do intersects because I do want those people who are right on that boundary of that 10-minute drive time. You can do target within the universe, say a block group inside of a city boundary, and you can do touches. This is if it's only touching the boundaries of each other, say polygon to polygon, block groups touching block groups. You can use this touches. Touches is where there is no overlap physically between the two, say two polygons or so on. It's only where they touch side by side. Or you can do touches or intersects. There's also a bounding rectangle overlaps. That is a bit more advanced, but let me know if you have a question on that. And then there's also the DE9IM, which is a very advanced GIS technique. It is the dimensionally extended 9-intersection model. That's a topological model, and it uses lots of programming to understand the intersections that happen between boundaries. So if you're an advanced GIS user, yes, Alteryx does have a custom DE9IM relation, and you would simply need the code that you would input for that relationship. So with this one, I'm just going to use the default of target intersects universe. You do have an option to output intersection object, and this is great if you're doing polygon over polygon. Say we want to compare trade area overlap, you can actually output that intersection object. But here we're doing point to polygon, just those customers inside those trade areas. And something else I'm going to do down here is you can see that we actually have, if you're a little used to Alteryx, what's very similar to a select tool. So there is rename fields and so on inside of a spatial match tool, as well as inside of join tools and some other tools. You do have an embedded select, which is extremely convenient. So I can go here in my select tool, and I can actually take out fields that I don't need. So you can see here, my target are the stores. I need my store number and city. I do need both of those spatial objects. But for my universe, which is the customers, I have their address, city, state, and zip. I also have some other information, but I don't really need that CAS information anymore since I used it for geocoding. So I can just quickly come here and deselect those fields, which is really easy. So I'm just actually clicking on these. These are deselected throughout the rest of the data stream. So it's really convenient just to be able to deselect my fields here. I don't have to write any language or code to be able to do that. I'm just going to deselect, and these are complete. So one thing I'm also going to do is rename a spatial object. So not only in your embedded select tool can you click on data types and change them, you can actually just change them manually right here, but I can actually rename. So I'm going to call this my customer spatial object. It's always a best practice to rename your spatial objects because the more you put things together and start appending data, the more spatial objects you have in Alteryx, where you can have multiple spatial objects per record. It's really great to have those fields renamed so you know what's my customer point and what's my store point and so on. So now that I've actually deselected fields that I don't need, and I've renamed my spatial object and so on, now I can actually perform this spatial match. So I'm going to add a browse tool to the M output or matched output. So this is going to show me what matched. Unmatched actually doesn't show my unmatched customers. Unmatched will only show what didn't match in your targets. So I can add a browse tool here, but hopefully all of my targets will find a match. And so my targets being the trade areas, I should have nothing left over here. I'm also going to change the configuration very quickly on my workflow. So I can click anywhere on my white space to access my workflow configuration. And I'm going to keep my connection progress as show. So I want to show that because I want to show the number of records coming through and the file size coming through as well. So I have this on, and when it's on, you can actually see this record count here. This is very convenient when you're working with large data sets, or you're filtering, or you're doing a top 10, for example. You can see that record number coming through and immediately know, okay, yes, this is working the way I wanted it to. Instead of having to add another browse tool and count records from that, you can quickly see your record count through that connection progress. So I've added my browses, and now I'm going to click Run. So it did a spatial match, and it ran in less than 1 second with almost 3,000 records. And that's matching those customers into those polygons. So that's extremely fast, especially when you're working with spatial data. So it has about 1,700 records that came through that matched inside of the trade areas. The reason the record number went down is there's actually some records that are outside of those 10-minute drive times. And for this analysis, we don't really need to look at those. We're really looking at all those customers that are inside those 10-minute drive times. So now we have them spatially matched. If I click on this, you can see the trade area, and then you can see the customers that are inside, intersecting, or actually touching that boundary there for each of these. I can also now look at my data. So if you view the data here, I've got my store number, my city, the spatial object for the store, and the trade area, along with that 10-minute radius size or drive time. I now have an associated customer with that. So now I've got a customer ID, a store number, their customer information for segment and responder, and that Latin long and geo level and that FIPS code, or Federal Information Processing Standards code, that you can use to match back to a block group or census tract, for example. So now I actually have this data associated. So I can see this person goes to store number 108, and then they are associated with store number 108. So this actually helps me really get to know my customers a little bit better. So here I've got store number 100. So you can see here near center of Denver there. And I can look at my data and say, oh, wait a minute. This record number 1, customer ID 167, even though they're in store number 100's trade area, they're actually affiliated with store number 101. So that's really interesting. I need to look at store number 101 and figure out a little bit more about it. I believe this one is 101. So for some reason, this customer, even though they're inside the trade area for store 100, they're actually going and bypassing that store and going into store number 101. So that really allows me to start asking more questions and saying, you know, why are they bypassing the store that they're usually in the trade area? Maybe it's because they actually are stopping by that store on their way back from work. So you might want to look at workplace information as well. They may actually be stopping by there after picking up children from school and so on. So there's a great way now that you have spatial match. You can actually look at the affiliated store number, and then you can actually look at the store number associated. So sometimes if I click on this map, if it's looking at a lot of data, it will hang for a moment. So I apologize for that delay there. And sometimes during a WebEx that happens as well. So I did want to say, even though it's thinking about that trade area, it's going to release that in just a moment there. And that only happens when I've usually clicked on a lot of data and I'm doing a WebEx. So it doesn't normally happen in Alteryx there. But I did want to add, with the spatial match, you do have a lot of options there to really get into your data and match them, not only customers to trade areas here, but we can also do polygons to polygons as well. As I mentioned, you can actually do overlap between trade areas, and this would be essential if you're looking at cannibalization, for example. So if you have quite a few trade areas and they are overlapping, you can actually see that intersection between and then calculate through this spatial match technique exactly the customers that are in the overlapping areas between both of the polygons. So that's really useful, because once you see that overlap area, you can start to do further, deeper analytics and say, all right, is it really a 50-50 split? You know, should each of these cannibalized stores receive 50% of those customers? Or is it something a little deeper? Do you need to look at where customers are working and so on, and figure out how they're aligning with each of those stores? So there are a lot of options there with that spatial match. And again, it's more than just point to polygon. We can do line to polygon, such as railroad tracks going into land use parcels. And then you can do all sorts of other with that DE9IM relation for those advanced GIS as well. So it looks like the workflow is thinking about something, and it probably is the WebEx connection that's doing this, and I do apologize for that delay there. So when that does happen, if it ever does for you in Alteryx, which is really rare, just hit the escape key, and it usually releases that where it's thinking about the data very quickly there. So I apologize. I may actually restart and start my Alteryx again on this one, just in the interest of time. So it probably is just the WebEx connection that's causing a hang to happen there.
Hi, Deanna. Can you try just hitting F5 and seeing if that will refresh?
See if that does something there. Again, apologize for this delay. So it's probably a little something with that WebEx, but I can just simply restart Alteryx and build this very quickly again on that. So again, sorry about that. It only happens during a WebEx as usual. So I can go ahead. I'll actually just change that really quickly on that screen, and then see if I can actually change this back. So let's see if that works. So it does look like there might be something going on in the WebEx, so I do apologize for that, because it looks like it's hard to hide that screen. And Courtney, let me know if you can still see my screen, actually.
I can still see your screen.
Ah, okay. So it might be a hang in the WebEx. Sorry about that. So one thing I can do, so I can actually start Alteryx again, and I'll just have it restart and see what happens, because is
the F5 not responding?
It is not, actually.
Okay.
Yeah.
Sorry,
so
everyone, for the inconvenience.
Yes. It's, you know, we handle these things with the WebExes, so we'll just actually figure that out and actually start Alteryx again. Thankfully, Alteryx is really easy for me to rebuild this. So, and here's my new Alteryx. So I will actually go here and just pull in the input data, just like before. And so here we have our stores and trade areas. And so this could be good, because you can see how quickly you can actually just build something in Alteryx. So I've got my geocoded customers. And then here is my spatial match. Very easy. And then I want to make sure that my store spatial object is really trade area. And then I'm going to go down, and I'm going to actually show a very quick tip and trick for those Alteryx users out there. I'm going to click on one record and then hold down Shift, click on the next record, and then I'm going to select and deselect highlighted fields. So now all of my cast fields are deselected. So now you get a little bit of benefit because of that little issue there on the webinar. So again, click on one field in your embedded select tool, hold down Shift, click on the bottom field you want to deselect, and then select, deselect highlighted fields from your options. So now I've got all those fields deselected, and I can actually go here to my spatial object, call that customer spatial object. And now I've renamed my data. And this time I'm not going to click on a bunch of data when I look at my spatial match and hope the WebEx actually holds up there. So now I've got my customers matched to their trade areas. So we will pick up where we left off there. So again, apologize for that. So now we've got our store spatial object, trade area spatial object, and the associated customer. We looked at, are they truly in their store trade area, or are they affiliated with a different store? And now we'll go into spatial and do a distance calculation. So distance is really useful. I'm going to actually perform a distance calculation from the customer to the store. And you'll notice that with distance, it only has one input. It doesn't have a double arrow. So if you use a tool that has a double arrow, such as a union tool, it can accept more than one input. But distance only accepts one input, and that's because it wants per record the ability to calculate distance from one spatial object to another associated spatial object in the data set. So we're doing store to customer, and this is record per record. So it wants one input there with everything per record. I'm going to actually connect my matched output here and then configure my distance tool. So for my centroid source, I actually want to say customer spatial object. And it's a good thing I did that best practice and renamed my spatial objects so I can actually see what they are instead of spatial object 1, 2, and 3. So now I have a customer spatial object and my store spatial object. I have an option here, so I'm going to output my distance. And if you are doing point to polygon, you do have an option of, if the point's inside another polygon, return the distance of 0. But for today, we're actually going to look at straight line distance and drive time distance as well. So as you saw last week, we calculated drive time for those trade areas, and those trade areas are based on minutes of drive time, based on the TomTom data. So we have with TomTom the options of peak, which is rush hour traffic conditions, off-peak, which is non-rush hour, or just a Saturday or Sunday afternoon driving conditions, and then night. Night is widely used by logistics and distribution companies, especially if they do have their trucks running at night. So you can actually use that data with the TomTom data. I'm going to keep it as off-peak, and then I can actually say we'll do a maximum of 30 minutes here for my time. We just really want to know how far out the distance is within that 30-minute drive time. We also have an output of cardinal direction. For those GIS people out there, you can output the direction in degrees. So you can say it's 75 degrees and it's to the east and so on. So cardinal direction is your north, south, east, and west. And this is really helpful. So you can say, oh, this store is east of the customer and this many miles. You do have your output units in miles, kilometers, feet, and meters. So you have a lot of options here. I'm just going to leave it as a default of miles. So now I'm going to add a browse tool and go ahead and run. So it's calculating distance in 1.8 seconds for almost 2,000 records, and that's customer to store. So it's really nice to be able to do that so quickly in virtual memory in Alteryx. You saw how fast that was. So now I've got appended to every single record the distance from that customer to their store, and the direction, the drive time, and the drive distance miles. So it's really nice to have that straight line distance miles and the drive distance miles. So someone may actually live only 3 miles away, straight line distance, but they're actually driving a little over 4 miles where they need to go. So it's really good to get that insight. We can look here at record number 1. It's the same record we saw before. I'm not going to click on a bunch of data here. You can see the customer and the store. So here's the customer. They're in that trade area because they're along this highway and it just meets that 10-minute drive time. And here's their affiliated store, 10 minutes. So directly, as you can see from the scale bar, they are 3 miles just about, straight line distance, but they're actually driving 4 miles and they're driving 10 minutes to get there. And it is that 10-minute drive time. Because they're right on the boundary there. So distance is really useful in this distance tool because you can append all of this information per record, and then you can start creating calculations such as what's the average drive time for all of my customers, how many people are actually driving more than 10 minutes to the store, and so on. So there's a lot you can do with this distance tool, and again, it's extremely fast in Alteryx. So now that we've looked at distance, and this is really the basic distance tool here, we can actually go on to the Find Nearest tool. And that's another tool in your spatial tool set. And this is really useful because it really does find the nearest points. So I'll bring this Find Nearest in. And I'll just bring it down here just to save space. And in the Find Nearest, I'm actually going to bring in my stores and my trade areas. So just like Spatial Match, you have targets and universe, and you have a matched output and an unmatched output. So again, as a best practice, your targets should be the larger polygon, and your universe should be the points or the smaller polygon if you're utilizing a polygon to polygon match. So here in my Find Nearest, I'm going to say we'll do a store spatial object and a trade area spatial object. And actually, I think it might be useful if we do reverse these because here I'm going to do point to point, and I'm actually wanting to do customers to the stores. So in this, I can actually quickly delete each one of these connectors by highlighting it and deleting it. And now I can say, I want my target to be the customer, and I want my universe to be the store. Since it's point to point, it doesn't really matter that on the target to customer here for Find Nearest, because my customer is going to be the spatial object, and then my universe, or what I actually want to calculate the next 3 to, is going to be my store. So what I'm doing is give me the 3 nearest stores to my customer. So my customer is the target here. Find the 3 nearest for me. But first I'm going to show you what it looks like when you do just 1 nearest. And then I'm going to keep my maximum distance at 20 miles here. And then we do have an embedded select as well. So we can actually select these, change the name of the spatial objects and so on. But I'm going to leave that as a default. And I'm going to add a browse after this match tool here. I'll go ahead and click Run, and Find Nearest again is extremely fast in Alteryx, 2.4 seconds, and that was also doing a spatial match and a distance as well. So now we're doing Find Nearest, and if I look at the information, now I actually have the customer information first because that is my target. So here's the customer address and their associated store number and all of their geocoded information. And then I have the affiliated or nearest store. So to this customer number 1, or record 1, their nearest store is store 100. It is a little under a mile away, and it's to the south. So I can just click on that record, and I can immediately zoom in. Here's my customer in pink, and then that store is about a mile away to the south there. So I can quickly see that customer. So they are in this store's trade area. This should be their nearest store. But what if I go back and change this Find Nearest, and maybe I want to do 3? I could do 10, I could do 20, I can even type in a number of nearest points to find. So I'm going to change about 50 miles, my maximum distance here, just in case, and change it to the 3 nearest points. So what this is going to do is it's going to actually create 3 records per customer, and it's going to rank them 1, 2, and 3. So as you can see here, the record count tripled. It went up quite a bit. Again, I need to re-show that for my connection progress since I started a new workflow there. But I just clicked on the white space for my workflow configuration and then went to connection progress and clicked on show. So now you can see my record count. And if I go back and look at my records, now for this record number 1 customer, I have 3 instances. They're affiliated with store number 100, which they should be. They're in that store's trade area. But what are their 3 nearest stores here? I can actually go and look at that. It's appended it to the end of this. So my 3 nearest stores are going to be store 100, 105, and 104 in succession, ranked by distance. So here's my find nearest rank of 1, 2, and 3, and here's the distance in miles. So my first store is that store 100, very close and in the trade area. The next store is that other store, and then the next one is store 104. So there's 105 and 104 in succession, and you can see to the south, southeast, and southeast for my cardinal directions as well. So this is really useful. Say if I want to relocate store 100, I may want to let that customer know, hey, here's your 2 nearest stores. You might consider shopping here at store 105 or even store 104 and so on. So I could actually do marketing outreach to those customers in the interest of relocating a store near to them. So the next thing I'm going to show you, now that we've done spatial match and find nearest and distance, is something really cool. It's one of my favorite things about Alteryx, and it is the EXPERIAN demographic data. So I'm going to pull in a tool called the allocate input tool. And these tools for allocate, input, and the demographic data are available in an additional bundle outside of core Alteryx. So if you are interested in this data set for the business insights data, please talk with your Alteryx rep, or you can go to the Alteryx.com website and look at products, and you can actually see the products that are offered there. So just to mention, this is an additional purchase along with core Alteryx, but you receive such a wealth of information, so the purchases are often very well worth it. So here is the allocate input tool. And you can see here I've got a data set for EXPERIAN data. I also have an option for the 2010 census data or a separate EXPERIAN full US data set. I'm going to use just the US data set and just quickly show you the wealth of geographies that are available with this data set, even before I jump into the variables. So as mentioned on the PowerPoint slide, we have block groups, census tracts, and so on, even those congressional districts, but we also have DMAs, metro and micro core-based statistical areas, places, which are actually cities. So if I click on places, I can actually get the city boundary for just about every incorporated city in the United States with this data set. So again, this is updated quarterly, so you have very fresh data. We also have state information and then various zip code information. You can do zip codes on their own, by county, DMA, or sectional center, and so on. So there's a lot you can do just with these geographies, and these are geographies that are provided as part of the allocate tool set with the EXPERIAN data. So I'm actually going to use block groups. Block groups are one of the smallest census boundaries available out there, and block groups are widely used whenever you are using demographic analysis. They are created by the census, and they represent homogeneous areas of populations. So for block groups, people in those block groups usually have pretty much the same education, they're the same socioeconomic status, they usually work kind of the same jobs, and it goes along with that proven theory that, birds of a feather flock together. Artists like to live near artists and so on. So you actually have a lot of those same similarities within block groups. And block groups are the smallest area for published sample data from the census. So this is not only the 100% data that you can get at the block level for all populations that complete the census, but it's the smallest area for published sample data. So there is the American Community Survey that the census sends out, and that sample data is rolled up into block group level. So I highly recommend when you're doing demographic analysis to use block groups when you can to get that finest granularity. They do range from 600 to 3,000 people, and the average is about 1,200 people per block group. So you do get a really nice use this type of area. There's about 211,000 block groups in the U.S. according to the census of 2000. So again, you've got a lot of options there with those block groups, and you can really see very quickly what's happening inside of an area demographically when you get to the block group level. So I'm going to expand and use the block groups for Colorado. And this saves not only space, I'm not clicking on all 211,000 block groups in the US, but all of my data is in the Denver area. So I'm just going to pull in the block groups for Colorado. I'm going to quickly show you what the block groups look like by adding a browse tool. So I'm going to run. It should run in just a couple seconds there. And so there's a little over 3,500 block groups in Colorado, and as you zoom in, you can see the denser the area, the smaller the block group, and that's so it keeps that average of 1,200 population, or really 600 to 3,000 people per block group there. So with this block group information, I'm actually going to look at variables. And the variable I want to use is the mosaic segmentation data. But you can quickly see there's a ton of variables, again, over 1,600 available through this EXPERIAN data set. I mentioned the Census American Community Survey, where you can actually get into citizenship, geographical mobility, language spoken at home, and so on. This is a survey sent out by the census every 1, 3, or 5 years, depending on the type of survey. And then basic variables. So you have your current year estimates, and these are the variables that are most widely used in demographic analysis. So you can see we've got educational attainment, household size, even income cohorts by household. So we can really drill deep into this granularity of data with all these variables, and I can get to it at the block group level or census tract or DMA and so on. So there's a lot of information you can actually obtain with all of these variables, even down to total households, total pop, density, and some more of those basic variables. You also can obtain the variables by percent. So I can get into educational and attainment by percent and actually have those percentages calculated for me already, so I don't have to set up a percent calculation as well. Not only do I have current year, but I have 5-year projections. The data set I'm using is sample data, so it's 2016, but it does project 5 years into the future. I also have my 2000 and 2010 census data as well. There's also business summary data. So this comes from the Dun set. That's also part of the data bundle when you purchase this additional bundle of Alteryx. So you can get into employees by SIC and NAICS division. You can look at establishments and so on. There's a lot of information there. And you can actually get into per address the information for the Dun & Bradstreet data itself. We also have consumer expenditure data. So you can actually see what people are spending their money on for consumer expenditures, say food and beverage. And again, this actually gets into very deep information. We can just get deeper and deeper and drill down into very granular data for each of these. So some of these are widely used by corporations around the world. Got daytime population, housing units, where you can look at housing value and so on. So you can look at the cohorts for that. And then you also have, I'll skip over Mosaic just for a moment because we're going to use that, occupation and employment. So you may want to see who's actually employed in certain industries and what industries they're employed in. And then you can get into retail demand and those Simmons product profiles. So Simmons is survey data, and they're taking a survey of populations. So for adults, they want to actually see, you know, what are the sports events they're looking at and so on. This could be quite useful for if you're in like the sports world and so on. This could be very useful information. So this actually, I'm going to use the Mosaic household distributions. So Mosaic is actually lifestyle segmentation created by EXPERIAN. And what it is 71 different segments. And these segments actually incorporate not only demographic data, but lifestyle data. So they take into account what type of car people like to drive, what type of house they like to buy, and how many rooms are in the house, and so on, how expensive those houses are, how they like to obtain their media. Do they do it through television and radio? Do they obtain it through the internet, and so on? So there's a wealth of other data that's wrapped into the demographic data that you just saw. And then these 71 segments are created. These 71 segments range from the most economically unchallenged people in the U.S. Or most economically successful people in the U.S. from the power elite here down to the most economically challenged. So you can see there's these really amazing names here for the names of the segments. I cannot take credit, although I'd like to be one of those people who create these great names for these segments. But these are widely used when you're analyzing populations and households. You can really get into those significant differences between types of people, and especially in retail and real estate, you're looking at what are those types of people who comprise my base of my customers. So we'll actually do that with the spatial match tool. So I'm looking at not only the household data here, but I'm actually going to look at the dominant cluster type. So I just want the dominant cluster per block group. So the cluster is one of those 71 segments, and this dominant type is going to tell me these block groups and what their main amount of segments are inside of those block groups. So I'm just going to click on dominant cluster type, and you'll see what comes out of each block group when I do that. So I'm going to run this again, and it's going to pull in the segment, and then I'll see the cluster type for each one of these block groups. So you can see here I've got block groups here, and then I've got the segment type for each one of the block groups. And I can actually get in the block group and actually click on each one and say, which block group is this? And it's L43, Homemade Happiness, is the dominant cluster here. So now I'm going to spatially match that and look at my customers and how do they spatially match to the data. So again, I'll go back and grab a spatial match tool. And with the spatial match tool, now that I'm using polygons and points for my customers, I want to use those polygons as the target. And then I'm going to use the customers as the universe. And then I want to look at the data and rename my spatial objects as they're coming through. So for my target, I have just a spatial object. For customers, just a spatial object. It would be a best practice here to rename those. So I'm going to call this block group spatial object. And then for my universe, get down to that spatial object as well. There we go. And call that customer spatial object. So now I can tell these two apart as I do the spatial match. And now I'm going to add a browse tool to this. And I'm just doing a target intersects universe just to see where those customers intersect with those block groups. So all the customers matched, all 2,678, and they matched to their individual block groups. So as I zoom in, you can see how the customers are matching to their block group. So now I have the block group name and key, the max type of segment, and now I have the customer appended. So for every customer, now I have their spatial object appended to the block group. So I can say that this customer resides in a block group that has a maximum type of P60. So just a little caveat here, that does not mean your customer is a P60 striving forward. It only means that your customer resides in a block group that the majority of people are P60 striving forward. So it's very important to know that. We do have consumer view, individual, and household data available through EXPERIAN, and it is able to match based on name, address, or phone number, and accurately profile exactly that customer if you have that information about them. So there is an additional data set that you can use to do that, but to where they reside, and the majority of people in that block group are P60 striving forward. So just a little caveat on that as well. Just in the interest of time, I'm going to add a summarize tool here I'm going to actually just group on that cluster type and then do a count of customers per block group. So here's my maximum type. I'm going to do a group by, and then I want to do the customer spatial object, and which is great that I renamed it so I knew which one was which. And I'm going to do a count. So I'm doing a group by customer objects, and then I'm actually going to see what that count comes out to be. So I'll add this browse here. And as that's running, it should show me all of the types. So there's 51 segments that my customer base is made out of. It is listing it in order of max type. So I want to actually sort and see in a descending order from my most highest number of customers per block group type. So I'm actually going to do a sort here, do a count in a descending order. And after this, we will actually see what our top 10 segments are for our customer base. So I'm running this count in a descending order here, and we'll start to see in this Denver area, what are our customer types. So I'll open this browse in a new window. Now you can see in a descending order, 054s, those striving single scenes, those are most of my customer base in the Denver area. And yes, that makes sense. There are a lot of striving single demographic types in the Denver area. So this definitely makes sense. We've got that aging of Aquarius, rooted flower power, and so on. Again, I can't take credit for these amazing names here. But I just want to do a top 10. So the easiest way to do that is use the sample tool. Attach my sample tool here and very easily do first n rows where n equals 10. And then I'm going to add a browse tool. And this is a pretty simplistic way of profiling your customers. If you want to get deeper into customer profiling, please feel free to reach out to me because there are some advanced techniques you can do to really get to know your customers. But again, this is a more basic view, but a great introduction into those EXPERIAN demographic and segmentation variables. So here are my top 10 segments for my customer base in the Denver area. So it was that fast, and you can see even though I had thousands of records, it was running in just seconds and performing everything I'd done earlier, the spatial match, the distance, the find nearest, another spatial match to demographic data, and so on. So in the interest of time, I just want to open it up for Q&A, and for any questions that I'm not able to answer today, I'd be very glad to answer those offline. So Alteryx will be sending those questions to me offline as well. Also, I wanted to add that you will be receiving the stores and trade areas, YXDB, and the geocoded customers at the end of session 3, which will be next week. Our own polygons on the fly. We're going to combine and intersect and actually look a little bit more into demographic data. So again, apologies for the slight delay there today during the WebEx, but I did want to open it up for any Q&A.
Thank you so much, Deanna. That was fantastic. We do have a couple questions from the audience. So the first one, is there a way to show the customers that did not match on a map?
Mm-hmm. There are actually. So you can actually do this match here. And if you have a unique identifier for your customer, such as a customer ID, you would then join back to your customer database. And then in the join, you would see what fell off of that join. So I could actually do that really quickly here. I'll take what matched. And then what didn't match for my full geocoded customer data set, I will actually match on a customer ID. It found it there. And then I'm going to add all browses. So we'll actually see what happens. So here's the 1786 that did match. And then there's the 1299 that did not. So what did match is coming out of the join. The right unjoined is connected to the customers here. And it's those 1299 that did not match. And here's their customer IDs as well. And you can see from the map, it's outside of those 10-minute drive time areas. So you can quickly confirm that spatially by looking at the map as well.
Thanks, Deanna. And then, unfortunately, we only have time to ask one question over the webinar. So we'll end it with, where can one find more information on spatial matching best practices?
Yes, I would recommend going to the Alteryx community, which is community.alteryx.com. There is actually not only a wealth of posts by users around the world on utilizing spatial match, but there's also some documentation created by Alteryx on how to perform spatial match most efficiently and really understanding that target and that universe relationship, as well as the options for those spatial relationships, intersects, contains, and so on. So I highly recommend the Alteryx community at community.alteryx.com.
Thank you, Deanna. This now brings our webinar to a close. Thank you, everyone, for attending. And as a reminder, our final session, Session 3, Spatial Processes and Maps, takes place next Wednesday on July 31st. Hope you all have a great day, and we'll see you next week.
Thank you all for joining. I look forward to talking with you next week.